Welcome to another enlightening tutorial on Flexteck. Today we'll dive into the foundational concept of C programming, data types. Mastering data type is essential for writing efficient and reliable code. Let's explore the world of data types in C together. In C, in C programming, data types are the building blocks that define the type of information a variable can hold. They determine the size and the format of the data, allowing the compiler to allocate memory efficiently and perform operations correctly. Understanding data type is essential for writing clean, efficient, and robust C code. Now, let's go to the basic data types. C provides several basic data types for storing different kinds of data. We have the int, representing the integer. We have the char, representing the character and strings. We have the float, representing a decimal value. We have the double, also representing a higher decimal value too. Let's talk about the int. This is the most common data type for storing whole numbers. As whole numbers integer, both positive and negative. The size of int can vary depending on the system architecture, typically 2 or 4 bytes. Example of an integer, we have something like this. Okay, example is like this. We have int age. Now the int is the data type, while the age is just an identifier. We call it a variable name. You can then say equal to, let's assign a value to it, 25. Now, this stores the age as a whole number, 25. You see, this is just a whole number. There is no decimal point after it. Now, let's go to the char, the char, okay? Now, the char data type stores a single character, which can be a letter, number, or a symbol. It typically occupies 1 byte and is treated as a small integer internally. Example of a char character, we have, okay, we have something like this, char, initial, equal to. Now, as you can see, this is the character, and this is the character, which is the data type, and this is what the identifier, which is the variable, and this is the value, a character, just a character, which is the letter, capital letter A. Now, let's look at float. Sorry, okay. Now, this is the float. The float is the data type. This is an identifier, and this is the value assigned to it, the identifier, which is a pi, which is 3.14159. So the float data type is used to store single precision floating point numbers, which represents numbers with decimal points. Due to limitation in binary representation, float values may have slight precision errors. So this is the example I've shown you. Now let's look at the double data type. Now the double data type provides double precision for floating point numbers, offering more precision than the float data type, but also using more memory, typically 8 bytes. Example of double data type, we have something like this. You start to declare it by double. Let's say let's use an identifier equal to 3.14159. Now this we use it to calculate area using a double for more precision. Are you getting it? Now this is calculating area for more precision. This is a large value which the float cannot what store, but the double can store it since it's 8 bytes, while the float is 4 bytes. Now, since we have looked at the primitive data type, which is the basic data type, let's look at modifier. Let me explain the concept of modifier for you more. Now, what is modifier? Well, modifiers, these are keywords that can be used with basic data types to alter their size and signedness. When we talk about signedness, we're talking about the signed and the unsigned type of data. Now, let's talk about the signed data. Now, the signed data type, this is the default for integer types and allows storing both positive and negative numbers. Example, you have something like this: int temperature equal to. Now, hold on. Okay, I did not put. Now, this is a signed data type and it's storing words, a negative number. Um, Assigned data type, when we use the sign to declare the data type, like for instance here we did sign int temperature, that means um, this identifier variable can hold both negative and positive number. By default, when we do int temperature, we are referring to what? A signed word integer. If we should erase this thing, we are what defining what a signed integer. Even when you if without the keyword sign, we it's the default data type of int is what? Sign. Okay, now let's look at the unsigned data type. The unsigned keyword, this restricts the integer type to store only non-negative values, effectively doubling the range of positive number it can hold compared to a signed integer of the same size. Now, for example, now as you can see, when we use this keyword to to define our variable or our identifier with the int, we are saying that this variable can only hold what? A positive number. Yeah, a positive integer. It cannot hold what? A negative integer. There'll be an error if you if you store a negative word integer here. So unsigned means that the value that is going to be stored in this variable will be what? Positive. Now let's look at the short modifier. Now, the short modifier reduces the size of an integer type, typically by half. Example of short is, let's assume this is short distance equal to 100. We use short to store what smaller integer value to save what memory. Now let's look at what the long modifier. Now, the long modifier, this increases the size of an integer type, often by doubling its example. Let me show you example. You can do long. Now we have something like this. This is a high value, but with this long, we can be able to store this value. Why? Because it's a large number. So always use long for a very large number. Now we have to introduce you to additional data types. Right. Like I said, these ones I have just shown you are the primitive or the basic data type in C. Apart from that, we still have other data types. So beyond the basics, C offers other data type for specific purposes. We have the void. This indicates the absence of a value. It is often used for function that doesn't return any data type. For example, when we are we are defining a function, we can do normal int the function name. Now, here, this int is signifying that what we are going to return will be what? An integer. But when we have void here, that means we are not returning anything, no data type, nothing. We are not returning anything. There's no return value. That's why we normally use void for this kind of thing. For example, to make it clear for you, let's say um, void sum. Then I would now do my, you have something like um, print f. Um, if we should run this kind of function, this we are defining, this function is just going to print 2 plus 2, and the value it's going to print out is what? 4. But since this is a void, there's no return type. But if we have to change this from void to int, assuming, let me say, now if we do like this, there's going to be an error. So what this is actually saying, we might just have to define, say, int a equal to 2, int b, int b equal to true. And we can just say return 2 plus 2. Now, you see, because of this return value, this return keyword here, what this function is expecting would be what? An integer. So it's going to return 4 is an integer, so it's going to return an integer. For us to print this out, we don't have to store it in another variable and use the printf to print it out. Unlike when we did the void, we print the value directly with the printf. Are you getting it? So when you have a return here, it's going to return whatever here. If it's an integer, here should be an integer. If it's a float, here should be a float. But since this is void, we are not returning anything. That means we cannot do return this thing, you get an error. Hope that is clear. Whenever you are using void, that means we are not returning any words, anything, or any data type. Okay, we have the enum, that's enumeration for full. This is a user-defined data type consisting of named integer constant. So in a later video, I will tell you more about the enum. So therefore, mm, like I said, okay, in a future video, we'll talk more on this type of data type, this enum. For now, we have to let go. Just know that it defines a user-defined data type consists of named integer constant. Now, let's look at choosing the right data type. Okay. Now, selecting the appropriate data type for our variable is crucial. Here, action tip. Use int for a whole number unless memory efficiency is a major concern. Choose float for calculation where slight precision are acceptable. Use double when high precision for decimal number is necessary. Consider unsigned integer when dealing with non-negative values like counters. Now let's look at benefits of using the right data type. Now, one of the benefits of using the right data type, it prevents errors and improves code efficiency. Another one is it ensures accurate representation and manipulation of data. And it enhances code readability and maintainability. By understanding and using the data types effectively, you can write C programs that are efficient, accurate, and robust. Remember, data type determine the size and format of data stored in variables. Choose data type based on the kind of data you need to store and manipulate. Now armed with this knowledge, go forth and write impeccable C code. Stay tuned for more tutorials and coding adventure.